In this problem, we're dealing with 30 students. Among those 30 students, we know that 4 cheat, and we are looking at a table that seats 5 students. We want to know what is the probability that exactly two cheaters are sitting at that table. Well, to create a group of 5, there are 30 combination 5 ways that you can create a table of 5 people. Now, from the cheaters, you want to know, of the 4 cheaters, what's the likelihood that you've selected that there are exactly 2 cheaters sitting at that table? Well, we know that we can't select 5 people, but only account for 2 in our numerator. So we've got to account for the other 3 students. Well, where would the other 3 students come from? The other 3 students would come from the remaining 26 students who aren't cheaters. So if exactly 2 of them are cheaters, then that means that the remaining 3 are non-cheaters, and we know that 26 out of the 30 students do not cheat. So finding this probability gives us approximately 0.109, which is about 10.9%. So very likely that this instructor has been able to avoid that issue. Now we want to know what is the probability that exactly 3 cheaters are sitting at this table together. So obviously this isn't the only type of problem that can arise. Having potentially more cheaters can just be equally as damaging. So from the 4 cheaters, we want to select 3. From the remaining 26 students, that means there are only 2 seats left that will be able to be filled by non-cheaters, and this is out of 30 combination 5 different group possibility. This probability is about 0.00073, which is less than a 1% chance. So the more cheaters that we would expect to have at that table, the lower the probability, since 3 of them are coming from the smaller group, but now only 2 are coming from the other. And I think this is incorrect. I think this should actually be about 0.009. So I take that back. 0.009 it was what this should come out to. In the next part, what is the probability that all 4 cheaters are sitting at this table together? Well, that means that from the group of 30, we can form 30 combination 5 different groups. From the 4 cheaters, we're going to select all 4. Well, there's only one way to do that if order doesn't matter. And from the 26, we're going to only select 1 student, so there'll only be 1 non-cheater sitting at that table. The probability is 0.000182. Excuse me, one more 0 in there, 0.000182, so very unlikely. So very unlikely that you get all the cheaters at that table. But if you want to look at the probability of getting at least 1, well, you can add up all the probabilities that correspond to having exactly 1, exactly 2, exactly 3. What is the probability that there are cheaters sitting at this table? Okay, think about what it means for cheaters to be sitting together. Well, that means that either we have 1 cheater, two cheaters, 3 cheaters, or all 4 cheaters. You can't have more than that, and if you're looking for the probability of having cheaters at this table, then 0 doesn't count. That's not a good possibility to consider. And you can't have 5 cheaters sitting at the table together because the max number of cheaters you have in this class is 4, based on what we know. So we already know some of these. We've calculated the probability of having 2, having 3, and having 4, which is 0.109 for 2. The probability of having 3 cheaters is 0.009, and the probability of having 4 cheaters is 0.000182. Well, to have 1 cheater, that's 4 combination 1 ways. From the 26, we're going to select 4 students, and that's out of 30 combination 5 different group possibilities. This probability is about 0.420 if you calculate it. So the sum of all these probabilities equals the likelihood that we have any number of cheaters at this table. So that means 1 or more. That comes out to about 0.538. So there's about a 53.8% chance that you have 1 or more cheaters sitting at this table, which is actually pretty high likelihood, in which case this instructor might want to do a little bit more research if they're that worried about it. Is randomizing or randomly assigning students to tables an effective technique? Why or why not? Well, it kind of depends on the person looking at it. The likelihood that you have 1 cheater at the table, well, that's pretty likely, but probably that you have more than 1 cheater isn't very likely. So it all depends on what you think is effective. How else could you make it effective? You could have students choose their own seats, but then you're more likely to have cheaters that choose to sit together.